heat waves, drought, tornadoes, hurricanes, floods, blizzards, bitter cold. Extreme weather has an incredible impact on people across the globe. On Mount Washington, our scientists brave some of the worst weather on the planet to improve our understanding of our warming world. All right, good evening and welcome everyone to Mount Washington Observatory's Science in the Mountains with support from MathWorks Incorporated. My name is Brian Fitzgerald and I'm the Director of Science and Education here at Mount Washington Observatory. And joining me this evening to discuss the legacy of Hurricane Irene is Ryan Knapp, weather observer and senior staff meteorologist, who's going to be joining us live from the Summit Weather Station. Also joining us this evening is Dr. Mary Stampone, who's an associate professor at the University of New Hampshire. In addition to being New Hampshire State Climatologist, she's also the chair of Mount Washington Observatory's Science Committee. And last but not least, we have Dr. David Hollinger, who's joining us as the director of the USDA's Northeast Climate Hub that's located down in Durham, New Hampshire. All right, so for those of you who aren't familiar already, I know we have quite a few returnees, the Mount Washington Observatory is a nonprofit, member-supported organization whose mission is to advance the understanding of the forces that create Earth's weather and climate. And we accomplish that through a few different ways. We operate our Summit Weather Station with around-the-clock weather observation and forecasting. We conduct research and product testing as well, and also develop innovative educational programs. So if you have any questions for tonight's speakers, and I'm sure you'll have many, and you're joining us on Zoom, please make sure you use the Q&A button, which you can find at the lower center of your screen on the lower toolbar for Zoom. We're going to be able to collect your questions throughout the entire program, so as they come up, please enter them there, so that way we can make sure to ask our panelists at the end, so make sure to get them in. If you're joining us via the live stream on Facebook, welcome and thanks so much for being with us. While we won't be able to have time to respond to your questions during the live program, we'll make sure that our Summit staff will try and respond as soon as they can following the program. So if you'd like to connect through Zoom next time for the next program, you can register using the link mountwashington.org/SITM, Science in the Mountains. Alrighty, so let's get into it. And before I hand things off to our first speaker, I want to get things going with a poll. So we've been doing this the first couple programs so far, and I'd love it if for those of you who are on Zoom this evening, if can join in on the poll. So we'll give you about a minute or so to answer some questions. First, we're curious, where are you joining us from this evening? I'm sure we have some folks joining from all over, including outside the US. Additionally, curious about those of you who support us as members, who's joining us this evening. And then we have some trivia questions as well. So a few different trivia questions that our hosts will, I believe, be able to answer in their presentations tonight. So you're going to want to make sure you keep an ear out for that. And so I see a few people responding so far. I'll give you a little bit more time. Some of those trivia questions, there's some good ones tonight, including how many hurricanes have crossed northern New England since 1900? I was pretty surprised by this answer myself. When it occurred, when did Hurricane Irene, where did it actually rank in terms of costliest hurricanes in US history? And then finally, from the Mount Washington flavor of things, what was the highest wind gust that was recorded on Mount Washington during Hurricane Irene? So I'll let the poll go for just another few seconds here, as I see we're getting quite a few responses. Alrighty, and we will end it right there, and we'll see. Let's share some results with everyone. All right, overwhelmingly, we have a pretty big Northeast contingency, not doing so bad for Mid-Atlantic and the Midwest. One person joining from the Southeast, welcome this evening. A couple folks from the Northwest as well. Earlier program for you, thanks for joining. One person from the Southwest and one person from outside the US. I know I did see Robert Monahan, son of one of the observatory's founding crew members, joining us, I believe, from British Columbia, if I'm not mistaken. So welcome to you. All right, quite a few members joining us this evening. And in fact, I have to say, we hopefully motivated quite a few of you. In fact, we had 6 or 7 people join after the program last week. So thanks so much for all of our new joins from last program. And for those 5 of you who said you're not a member yet, but you're going to join after this program, welcome and thank you so much for your support. All right, how many hurricanes have crossed northern New England since 1900? Quite a few of you thought 7. And it went down from there. When it occurred, how did Irene rank as the costliest hurricane in U.S. history? Most people thought it was about the 4th. Quite a few of you, about a dozen, thought it was the 1st. We'll see, we'll find out. What was the highest wind gust recorded on Mount Washington? Quite a few of you thought 141 miles per hour. All right, some good guesses there. All right, well, let us get right into it. Enough from me, let's hear from our speakers this evening. So we're going to kick things off by handing it off to Ryan Knapp, who is live from the Summit Weather Station. Ryan, I don't know if you can hear me okay up there.
I can.
Excellent. All right. Well, thanks so much for joining. So a little background here. Beyond being a great forecaster and an excellent meteorologist, we wanted to include you in tonight's program, not only because of those things, but because you were working for the observatory as a weather observer back in August of 2011 during the time of Hurricane Irene. And to kick things off, I'd love it if you can give our audience a reminder about what the meteorological story of Hurricane Irene was.
Sure. So we'll start off with just providing a timeline of events that occurred with the hurricane as it was moving up. And then we'll start discussing how it impacted the summit specifically. So we'll start off here. So it started off on the coast of Africa, the west coast of Africa, as a tropical waveform on August 15th. So it was kind of this disorganized conglomerate of thunderstorms that wasn't really forming into anything of significance quite yet. But as it progressed across the Atlantic, by August 20th, it started to become a tropical storm criteria, and that's when the National Hurricane Center gave it the name of Irene. Now, on August 21st, that's when it started to affect the Lesser Antilles, so that would be the Eastern Caribbean. And as it was passing through there, it was still kind of disorganized. It had met tropical storm criteria and remained as a tropical storm as it was passing through there, but it didn't bring too much in the way of rain. It was only about 3 to 5 inches for all the islands that were around there. Winds were about 68 miles per hour sustained and gusting a little bit higher than that. But it didn't do too much damage on those smaller islands on the east side. It wasn't until it started to hit the Greater Antilles that it started to do a bit more significant in the way of rain and wind. And as the first island that got affected was Puerto Rico, which you can see located in the right-hand side here. Now, as it passed through there, it started as a tropical storm, but as it passed the island and started to exit, that's when it boosted up to the Category 1 criteria. But as it passed the island, most of it only experienced about 70 mile per hour winds down at the surface level. Now at the higher elevations, they estimated a wind gust of 111 miles per hour. So their island has about 4,000 footers as their high elevation points. So a little bit in elevation provided those significant winds. Now on the east side of the island, they were seeing significant amounts of rain in addition to those winds, and also high tides and coastal surge. So the peak rain that they measured was 22.04 inches, so quite a bit of rain as that low was passing by them. As it exited, it then started to move up towards the Turks and Caicos and Bahamas, and by then it strengthened even further and reached a Category 3. And that means it had a sustained wind of about 120 miles per hour at its peak. And the highest winds that the islands down there recorded was estimated to be about 140 miles per hour. So a pretty significant wind event down there as it was moving around those islands, and that it was also still delivering those heavy rains. So some of the islands were seeing upwards of 13 inches. Most of them were averaging around 10 to 11 inches. So quite a bit amount of moisture moving into those smaller islands as it was starting to move up the eastern seaboard. Now by the 25th and 26th, it started to pull away from those islands and start making its way up the eastern seaboard. It had remained far enough offshore, so it didn't really affect the lower southeast, so Florida, Georgia, and most of South Carolina kind of escaped the full brunt of the storm. So they were getting a little bit of rain on the outer edges of it, And winds did increase a little bit, so some of the areas were seeing winds of 40 miles per hour and an increased tidal surge, but nothing in the way of the heavy rainfall and winds that the islands down south were reaching. And by August 27th, that's when it started to reach landfall in the lower 48, and it reached the Outer Banks of North Carolina. And when it did, the waves were about 6 to 9 feet tall. There was a pretty significant tidal surge, which eroded a lot of the Outer Banks, and some of the highway that runs along there was cut off because of the tidal surge and flooding that occurred with the storm as it was moving through. It was a Category 1 as it moved through, so winds were about 60 to 85 miles per hour, and it dumped a lot of rain, so 10 to 14 inches on average around that region, in addition to all that coastal flooding that was occurring with the tidal surge. So there was a lot of flooding not only on the Outer Banks, but in the Inner Sound as that water was kind of rushing in, but also coming from the west side as the rain was washing down back towards the ocean. So a lot of flooding down in that area. And also within that area, there was a lot of tornadoes as it was moving by. So a pretty significant storm as it was moving by the Outer Banks. It then slid off the shore right around Virginia and remained a little bit off the coast. It continued to decrease in strength and reached about a tropical storm as it reached New Jersey. So it decreased pretty rapidly when it made its second landfall in the lower 48. And by the time it reached the Brooklyn area, it actually had already decreased to an extratropical cyclone. So it further decreased by the time it hit lower Manhattan. Now, at the time, they were kind of organizing and trying to get everything strapped down because it was the 10-year anniversary of September 11th. So they were kind of scrambling, worrying that the system was going to be doing a lot of wind damage there. And luckily, it mostly was wind down there, and the winds decreased rapidly as it started to hit the southern parts of New England and New York State. And by August 30th, the low eventually made its way up to Newfoundland and exited through a frontal system that was up kind of near Newfoundland and Greenland and kind of got absorbed with that. But as it was passing, you can kind of see here, it was a massive storm. So while it did not provide the winds in the lower elevations, it provided a lot of rain with the system. But to give you an idea, we'll look at the track of the storm here. So the various colorations that you see here are the intensities. So the blues down near the Lesser Antilles, that's when it was a tropical storm. It moved into this green coloration around the Greater Antilles. And then as it moved by the Bahamas and those islands, that's when it intensified to the Category 2 and then eventually a Category 3 at its peak. And then as it moved up the eastern seaboard, it downgraded to a Category 2 kind of in the leeward side of the Florida and South Carolina and Georgia area. And then by the time it reached the Outer Banks, it had decreased to a Category 1 and continued to decrease in intensity as it head up the eastern seaboard here. Now for our location, we started forecasting this as early as August 17th. So that's when we were having a shift change. And the reason we were looking at it so far in advance is we wanted to know how it might be impacting us, because we do a lot of work outside during the summertime, making sure our instruments and transportation and everything are up on par before the fall and winter season happen. So we were kind of looking at it preliminarily, taking it with a huge grain of salt, because that far out, the storm could have done a lot of things, you know, curved off and gone out to sea, or it could have spun further inland. So we were just kind of looking at it preliminarily and kind of getting an idea for it. It wasn't until August 27th or 22nd when we started putting it into the forecast. And the reason why we put it so far in advance was to make sure people were aware that it was going to start affecting their weekend. That would have been the last weekend in August, and we wanted to make people aware that if they were going to be vacationing up here, you know, before school started or just after the school season started, that they were aware that this might impact their plants, because there was a lot of moisture and winds potentially with this storm. And by the 27th and 28th and 29th, that's when we start putting it into our higher summits forecast. Now, looking at the various higher summits forecasts for that time, the three boxes on the top here are the 27th, the middle boxes of the 28th, and the lower boxes of the 29th. Now, the things to kind of point out here is the top boxes. You can kind of see that the winds were relatively low initially before the storm got here, so averaging about 5 to 20 miles per hour at time. But then as the lows started to move in, that's when the rain started overnight and into the 28th, and it picked up in intensity and also embedded a lot of thunderstorms as it was passing. And then on the 28th, we saw winds rapidly increasing. By the end of the day, we were expecting 65 to 85 miles per hour sustained winds. And then during the overnight hours, that is when we saw the peak intensity of the storm. And in this forecast, right in the middle box here, we had forecasted winds of 95 to 115 miles per hour, and that's sustained winds. And we were forecasting slightly higher winds than that as the storm moved through. And then as the storm exited, things decreased rapidly as far as winds go. And what was more significant with that, though, is we were seeing temperatures drop drastically. So we went from 50s as the storm approached down to the 30s as the storm exited. So quite a significant difference between the two. Now for the summit's impact, we saw 6.78 inches of rainfall between a two-day period. So pretty good amount of rain, but more significant was that 6.66 inches fell on the 28th alone. And that is our August rainfall total for a 24-hour period. So that's going from midnight to midnight in one 24-hour period. So a significant amount of rain fell within a short period of time. And that wasn't only for us, that was for the rest of New England, which we'll show you in just a second. And in addition, there were a lot of pressure changes in temperatures. So we'll touch upon those real quick. So the first graph that you see here, the bottom axis is time, and then the other sides are millibars on the left and inches on the right. So this is measuring pressure. So this is a 5-day span to kind of give an idea of the pressure trends during that time. So before the storm and after the storm, we were averaging close to 24 inches, which is about average for the summit during the summer months. But as you see the center of the low starting to move in, or the eye of the storm, you can see pressure dropping off rapidly and bottoming out around 23.17 inches. So it almost dropped nearly an inch of mercury as it moved through. So pretty significant and strong storm as it was moving through. And then as soon as the eye passed us, it started to exit and pressure quickly rebounded on the upside or on the backside. And that's why you see the pressure trending on the right here. Now looking at temperature, kind of the same situation. So ahead of the storm, we were kind of averaging 40s and 50s, which is around the seasonal averages for that time of year. As the low passed, temperatures dropped rapidly within a 24-hour period, going from a high of about 56 degrees, dropping down all the way down to about 36 degrees as the low started to exit. So we dropped about 20 to 30 degrees in a short amount of time. So quite a difference between one day and the other, especially if you were out in the backcountry. Now looking at our winds here, these are our haze charts. So they go from midnight to midnight. Midnight would be the top of the chart here. They then rotate around. The thing to tell about these are the further away the line is from the center of the chart, the higher the winds are, and the thicker the line is, the gustier the winds are. So as I was mentioning, winds were relatively low at the start of it. So winds were only about 5 miles per hour initially. But as Irene started to move up, winds were starting to become more gustier and stronger. And we had a peak gust of this day on 104 miles per hour as the low was approaching us. Then as the eye passed over us, we dropped to about 10 miles per hour. So that dead calm that everybody talks about as the eye moves through, we experienced that here on the summit because it was almost directly overhead. Then as the low exited, you could see the the winds once again increasing. And by 1:30 a.m. on the 29th, we saw our peak gust of 120 miles per hour. So that's the answer to that poll question we answered earlier. Next up is precip. So it's a real quick preview. So this is a time lapse of all the rain that fell along the eastern seaboard. So you can see a lot of yellows, reds, and oranges embedded there. And it provided a lot of rain. So this is the rainfall total maps that you see here. So you can see there was a lot of rain down North Carolina area. So that's where they were seeing those 13 to 15 inches of rain. And then as it moved up, they were still seeing about a foot down in New Jersey, Delaware, in those areas. And then as the system moved up into New England, it did decrease in rainfall amounts. You can kind of see on this map on the right-hand side here. But you still see a lot of greens and even some embedded yellows. So the region was still averaging anywhere between 6 to 8 inches of rain, with some areas seeing upwards of a foot of rain falling in that short time span. So not only did it cause flooding as the storm moved through, but some of that flooding lasted 2 or 3 days afterwards as it was all starting to drain out. Lastly, we'll look at a kind of a map showing all the flood levels of the various rivers that were around the region. So all the dots that you see here are river gauges that either met or surpassed flooding stages. And the ones, if you can make them out, that are red indicate that those stations were reporting record flooding for the time. So back when the storm was moving through, they were their all-time flood levels. And then on the left here, you can see the Connecticut River as it drains into the Long Island Sound, and all that silt and debris basically coming from Vermont, New Hampshire, Massachusetts, and Connecticut as that river moves through, dumping out into the sound here and just kind of creating a muddy, milky mess down there as it exited off the coast, basically. So that's my presentation. I'll kick it back to you down in the valley there, Brian.
Thanks, Ryan. That's really helpful to remind us all a little bit about the meteorological perspective on things 9 years ago now. So pretty amazing, especially when we consider just a couple weeks ago, saw some exciting tropical weather, and the fun never ends. And certainly lots going on in the tropics right now as well. So with that in mind, love to bring Mary Stampone into the conversation because so far we've talked about weather. So we're talking about a single event. And Mary, you're a climatologist. You are the state climatologist as well. And you focus on very, very long-term weather and weather patterns, also known as climate. How does this single weather event stack up from a historical and climatological perspective?
All right, well, thank you, Brian. So in thinking about a single weather event like Hurricane Irene in terms of climate, we first need to look at the history and then consider how they will respond to the effects of a warming climate. While New England is known for wild weather generally, we are fortunate in that hurricanes are relatively infrequent when compared to the occurrence of non-tropical storm systems. And when they do happen, most are weaker than those that impact the Gulf Coast in the southeastern United States. The map to the right here shows the tracks of all tropical storms in green and hurricanes classified by intensity that have crossed northern New England since 1900. In total, 19 such tropical systems have made their way through Vermont, New Hampshire, and Maine for an average occurrence of about 1 to 2 events per decade. Since hurricanes form over the warm waters of the tropical Atlantic, Caribbean, and Gulf of Mexico, those that reach New England commonly weaken this far north. Because of that, the majority of the tropical systems that reach northern New England are weaker tropical storm force systems with wind speeds between 39 and 73 miles per hour. A few, though, 4 to be exact, have made their way to northern New England, maintaining their hurricane strength, including Hurricane Bob, which made landfall at Rhode Island and crossed over Massachusetts into the Gulf of Maine, skimming the coast of New Hampshire and Maine before making landfall again as a tropical storm. Like Bob, most of the tropical storms that reach New England come from the southwest and cross closer to the coast, bringing strong winds and storm surge to coastal Massachusetts, New Hampshire, and Maine, as well as heavy rain inland. Less frequently, a hurricane may come up from the south and cross through the interior of New England to the west, like the Category 3 Long Island Express, which passed over western Connecticut, Massachusetts, and Vermont in September of 1938, or through eastern Vermont and New Hampshire, like Carol in 1954, and more recently, Hurricane Gloria. Like most New England hurricanes, Gloria formed in the eastern Atlantic and made its way up the U.S. East Coast to southern New England. Once a massive Category 4 hurricane, Gloria weakened to a Category 1 before making a second and third landfall in Long Island and Connecticut on September 27th of 1985. While New Hampshire was relatively spared the worst of the storm that devastated North Carolina, it was strong enough to produce hurricane force winds that generated a storm surge up to 3 feet along the coast of New Hampshire and Maine, and a wind gust of 127 miles per hour at the summit of Mount Washington. Across the interior of New England, winds knocked down trees, damaged crops, and cut power to nearly 2 million people across New England, while heavy rainfall caused localized flooding across the White Mountains. While Gloria made its way across New England as a hurricane, several tropical storms too have followed Gloria's path, including Hurricane Irene. In 2011, Hurricane Irene made its way up the East Coast as a Category storm, just slightly west of the path Gloria took in 1985. Compared to hurricane-strength storms like Gloria, Irene was slower and more diffuse as it moved over the mid-Atlantic, reaching New England as a tropical storm. Although damage from Irene was less than feared across the mid-Atlantic, the most significant damage occurred hundreds of miles inland across upstate New York, Vermont, and New Hampshire. Part of this was because of some unique meteorological features which allowed Irene to last longer and grow larger than most tropical storms do. And with its inland path, coastal New Hampshire and Maine experienced only minor storm surge, gusty winds, and little rain. But further inland, tropical storm force winds knocked out power, but the most devastating damages occurred not because of the winds like Gloria, but because of flooding caused by heavy rain. So despite being technically a weaker storm than Gloria, Irene's size and longevity allowed it to impact far more people than it would if it had been smaller in size but a higher storm category. So this is why it's important to assess hurricane risk and impacts, not only in terms of a storm's category, which is defined only by wind speed, but by the other environmental factors that determine its path, size, and duration, as well as the hazards generated by wind, storm surge, and precipitation. As the world warms, the additional heat added to both the atmosphere and ocean will likely lead to stronger hurricanes that produce more precipitation. Why is this? Well, first, warmer air can hold more moisture than cold air. For a hurricane or any coastal storm, a warmer atmosphere can evaporate more water from the ocean's surface, increasing the water content of the storm. The intensity of heavy rain, including that produced by tropical cyclones, increases in a warmer world, and the heaviest rainfall amounts from intense storms like hurricanes has increased on average by 6 to 7% compared to a century ago. Like the atmosphere, oceans are warming as well. And because hurricanes are powered by heat from the ocean, the more heat available to support the storm, the stronger the storm will be. The ability of recent hurricanes to rapidly reach and maintain very high intensity is consistent with the expectation of stronger storms in a warmer world. Then beyond the storm itself, rising sea level and coastal land surface characteristics influence the extent of storm surge as well as the amount of freshwater flooding from inland rainfall. Human-caused global warming has contributed to the observed increasing trend in North Atlantic tropical cyclone activity since 1970. As the atmosphere continues to warm, there will be greater potential for stronger tropical cyclones globally. Climate model simulations of tropical cyclone activity, which are shown here for the present climate, as well as the late 21st century. This all indicates that while the number of tropical storms will likely remain steady or possibly decrease, the most intense storms will likely occur more frequently and produce more rainfall than present day. This means that in the future, Atlantic hurricane rainfall and intensity will likely increase, which in turn increases the risk of freshwater flooding along the coasts, as well as for inland areas like those impacted by Irene. So for more information on observed and potential changes in hurricane activity, I encourage you to check out the 2018 Fourth National Climate Assessment. And for those of you interested in the historical hurricane data showed here, they are available free online through NOAA's interactive Historical Hurricane Tracks database.
All right, thanks, Mary. Appreciate that. It's actually, I'm not sure. Did you reveal the answer? How many hurricanes, true hurricanes? 4?
I
Right,
did.
4. Not very frequent that we get hurricanes that actually last as, I guess, true hurricanes by the time they make it to northern New England, right?
Right. Yeah, they
Yeah.
usually dissipate. We get a lot of post-tropical systems that cross us, but very few actually maintain their strength this far north.
Yeah, well, so for those of you who are joining our mostly northeast focused audience tonight, perhaps you remember a few of those. Some of those definitely a long time ago. Many of those before I was around. But lots of tropical systems, not always necessarily a true hurricane by the time they make it here. So thank you, Mary. Appreciate the perspective from the climate sense of things. And then last but not least, we have David Hollinger joining us this evening. So, David, I'm curious. Well, first off, can you hear me okay?
Yep.
Great. And I can hear you as well, so even better. David, I'm kind of curious. So, all right, we have Ryan who's talked about the weather. We've had Mary talks about the climate and how Hurricane Irene fits in. I'm kind of curious specifically from you and your focus. I mean, I know you focus on forestry, agriculture, those sorts of practices, but also just sort of from a broad-based impacts perspective. I'm wondering if you can tell us a little bit more about the impacts that we saw, mostly from this region from Hurricane Irene.
Absolutely. I'd be glad to, Brian. We've heard a lot these days about billion-dollar weather disasters. Well, Irene was a $16 billion weather disaster. And in fact, for those that were paying attention, when Irene struck, it was the ninth costliest tropical cyclone to hit the U.S. But if you had kind of voted for the first, you were kind of right, because at that time it was the costliest Cat 1 or below storm that had ever arrived. Just as sort of for comparison, though, I put up the estimated costs of the top 5 costliest hurricanes that have struck the U.S. And you can see that Hurricane Katrina is just way out there on top, although Harvey, which, if you remember, sort of absolutely inundated Houston just a couple of years ago, was also just another $100+ billion storm. So Irene at $16 billion, big, but maybe not absolutely enormous. But the impacts across the US, they really were pretty major. 45 people were killed. Over 7 million homes and businesses lost power. I know that I'm down in Durham and was here when Hurricane Irene struck, and we lost power for a week. I'm sure many of the listeners have sort of similar stories. And as we heard from Ryan, and Mary, it had an unusually broad impact. It sort of impacted 13 states, Puerto Rico, as well as Canada and a number of other islands beforehand. It was also quite unusual in that the storm surge ranged between 4 and 5 feet, all the way from North Carolina to Massachusetts. So if Irene was kind of a only maybe a Cat 1 storm, or even less when it arrived up here, but a Cat 1 when it first hit the US, why was it such a big disaster? Why was it number 9 and number 1 most impactful Cat 1 storm of all time? Now, Mary has given us a couple of pieces that go into that. It was unusually large and slow moving, but in terms of the dollar signs, what really matters too is the track. Irene went right up along the coast, right along some of the most expensive property in the country, and as Mary said, it moved slowly. Another factor which was really quite important, and it's over on the right-hand side of this up in the figure, and I hope that the picture is not quite on top of it, because something else about Irene that was really unusual were the preceding conditions. The August of 2011 had been unusually wet for the Northeast. And what this figure on the right is showing is the soil moisture just prior to the event. And the green means that basically it means the soil was very wet. And in fact, in New England at that time, it was sort of 95 to 99% sort of saturated in a sense, in that it could hold very little additional water. So whatever arrived from Irene basically ran off immediately. The soil was already saturated. So those were 2 additional factors that really kind of brought the disaster up for this event. Now, when the federal government sort of looks at disasters and responds to disasters, it's not just one agency, although FEMA is the lead agency. And even within FEMA, it's not just one program. What I've listed here are kind of the major disaster programs, and I've put down the response from FEMA for Hurricane Katrina just for the state of Louisiana. FEMA also organizes their assistance by state, so you have to sort of add it up for all of the states. But The first kind of assistance that they offer is basically individual assistance. So this goes to homeowners, and basically if your house is damaged or you need to move, they will help with repairs, they'll help with rent, and just other things like that. They brought in trailers, for example, for Hurricane Katrina. A second category is the FEMA public assistance. So this is where they're removing debris, they're rebuilding the infrastructure, basically roads, bridges, sewage systems, police, hospitals. They'll also go in and provide policing during these events. You can see in Katrina's case, that was about $12 billion. And on average, if you look at these disasters, the public assistance is which goes to the states and towns and whatnot, is normally about double what the individual assistance is. FEMA has a program after the fact where they go in and they help mitigate future disasters. That's becoming a bigger part of their budget. For Katrina, that was another $1.5 billion. And they also administer the National Flood Insurance Program. So that's completely separate from everything else. And in the case of Katrina, the losses paid out exceeded $16 billion. And that's just from the government. I mean, the private industry had additional losses. Also, the Small Business Administration, they make low interest disaster loans. So there's a whole range of pieces that go into the disaster response. If we look at kind of one aspect of this for Irene, and the easiest one to get your hands on is the individual assistance, the assistance that goes to homeowners and people that were basically the victims of the flooding and other aspects of the disaster. So in all, FEMA provided assistance to 13, public assistance to 13 states and Puerto Rico, and they provided the individual assistance to over 130,000 people. And the map on the right kind of just shows the dark red means it's public and private assistance, and if it's a dimmer yellow, that means just the public assistance, rebuilding bridges and roads and whatnot. So just looking at the individual component at this point, this is kind of what happened sort of in millions of dollars for the various states. And it's kind of interesting, you look at here, New Jersey by far and New York were the two largest and places where Irene was most costly, with over 70,000 people between those two states. After New York came Pennsylvania, North Carolina, and Puerto Rico. And then down here at about, what would that be, sixth place, I guess, was Vermont, where $23 million of assistance was doled out, and that went to over 3,600 people. And you can see comparatively in New Hampshire, far fewer people had claims and far less assistance was provided. So the question is, why then, if the disaster level in Vermont was well below that of New York and New Jersey and all these other states, why is Irene so associated with New England, and why is it sort of Vermont storm? I think there are a couple of reasons for this. I mean, probably in terms of New Jersey and New York, it was only a year later that Sandy arrived. And, the superstorm Sandy, or whatever you want to call it, was far more devastating in these states. The sort of disaster payments from FEMA were 4 times higher in New Jersey and 10 times higher in New York. So talk of Irene just kind of went out the door after that. Another aspect about Irene and Vermont especially was the unusually large sort of public assistance that went out. This was the damage to the infrastructure. In the case of Vermont, it was over $100 million, which was about 5 times the amount that went to sort of the individual assistance. And normally they're much closer, they're much more equal, maybe 1.5 or 2 times the public, but it was 5 times. So there was an awful lot of public infrastructure that was torn up by Irene in the state of Vermont. Also, on a per capita basis, the assistance and the need in Vermont was much greater than any of the other states in this storm. The actual damage in Vermont, it was extensive. I mean, there was over 500 miles of roads were impassable, over 1,000 culverts were washed out, over 200 bridges, and over 1,600 homes were damaged. At the time, more than a dozen towns were isolated. And if you remember, especially if you were up in Vermont, you certainly remember Route 4 was impassable for weeks. In fact, there was, many towns were isolated for weeks. And I think that's maybe contributed to it too. It was an ongoing story in the news, when was this town going to get reconnected? And there was also, I think, a tremendous amount of public spirit in the rebuilding that went on. I mean, Vermonters just didn't wait for, they didn't wait for the go ahead. They just started rebuilding immediately. There were concerts, everything else. So it was a great response. Now, so far I've been talking about the economic losses. I wanted to just touch briefly on the ecological impacts, what happened to the natural world. And honestly, Irene was kind of pretty small potatoes when it comes to environmental or ecological impacts. Tree loss from the winds was really mostly minor. The Great Ice Storm of 1998 was far worse. There were several million acres of trees that were impacted. And in fact, you can still see many sort of legacy impacts from the ice storm of 1998. There was, of course, localized, devastating impacts to stream and river life, but flooding events are, they're a fact of life for the ecology of rivers, and they recover. One kind of interesting factor is Hubbard Brook, and there's in the bottom right-hand corner, that's one of the gauged water sites at Hubbard Brook, which is in the White Mountains. I think most of you probably know about Hubbard Brook, an experimental watershed. They were monitoring when Irene hit, and they reported that there was over a year's worth of erosion and phosphorus loss leaving their sort of stream ecosystems in less than a day from Irene. And that's kind of typical of these major flooding events. So I'm going to wrap it up here. When Irene struck, as we said, it was the 9th costliest tropical cyclone to hit the US and costliest Cat 1 ever. But 9 years later today, Irene ranks 16th costliest, and it's the 3rd most impactful Cat 1 or less. And that's just in 9 years, it's lost sort of 7 places. So the question is, what happened? And what happened is Sandy happened in 2012, and Harvey, Irma, and Maria happened in 2017, and then Florence and Michael happened in 2018. So these storms, were 2nd through 5th, or now 2nd through 5th, as well as the 10th and 12th, and combined have over $300 billion worth of losses. So maybe rather than asking what happened, we should go back to Mary and say, what is happening? What is going on here? And maybe we can talk about that more with the questions, Brian.
That's great. Thank you so much, David, for giving that background as well. A lot of different angles and certainly personal experiences as well. And just real quick, before we open it up to questions from the audience, I see quite a few coming in already, and please get your questions in now while you're thinking of them. If I can have my other panelists, Mary and Ryan, if you want to join as well, because before we open up to questions from the audience, I'm going to be a little, I want to ask some questions myself. And Ryan, I mean, sort of thinking back to some of the things you presented about, as I mentioned, I mean, you were on the mountain during this event. And I'm just wondering, I mean, you've seen so much of what people would call extreme weather most of the time during your experiences on Mount Washington. I mean, what stands out about Irene to you? And what are some of those things you really recall? And I know you even touched on some of the challenges of forecasting, but what stands out for you?
It'd probably be the winds now, and I say that because typically we see our higher winds between the months of October to May, and that's when we see most of our hurricane force winds. So to have a triple-digit gust occurring in August is kind of an unusual event. As I mentioned earlier, it was the 6th highest that we recorded. So it was a strong wind event that most people probably weren't expecting, or if they weren't paying attention to the forecast, weren't expecting. So it's kind of unusual to see those kind of high wind events during the summertime. So that would be the first thing that sticks out, and then the other would be the flood damage. While Vermont got the brunt of it with all the flooding that was just covered in the recent presentation, New Hampshire experienced it as well. Around the White Mountains, a lot of erosion. Some of the roads got a little bit of washed out or impassable, and so the trails were also impacted. Some of them had a lot of erosion that occurred and a lot of downed trees. Those were the two things that were kind of hand in hand with that particular storm. So it was a lot of cleanup and a lot of recovery. And some areas actually took 2 or 3 years before they even got close to what they would recall as recovered. So pretty significant storm around here.
Yeah, thanks, Ryan. Yeah, I know a lot of that stands out in my mind, and even do see a question that we might get to in just a little bit about some of those impacts that if you're a hiking fan in White Mountains, certainly, the storm of Hurricane Irene stands out in your memory. Mary, I mean, kind of coming back to you for a second, I mean, just sort of bottom line it for us. I know this question has probably already been asked in the chat here. What is this? I mean, what is, in context, what does Hurricane Irene and subsequent and future tropical weather hold for New England? What should we expect?
We really should be planning for more rainfall, particularly inland. Storms like Irene show that hurricanes are not only coastal events, they can have significant impacts further inland. And when you have storms that are going to be stronger, they have more to them, can go longer, like Irene did. And they're all going to produce more precipitation. I mean, we're already seeing that with Hurricane Harvey in 2017, just smashed records for rainfall. It produced rainfall rates of 4 inches an hour. Other storms, and then that was followed by Florence in North Carolina. So, I mean, we can't expect that here, will be more tropical storm force or maybe category 1 hurricanes. But overall, it's going to be the rainfall. And Irene already showed us what that type of rainfall can do to our infrastructure. And we need to be prepared for that.
Thanks, Mary. And sort of on that same line of thinking. So, all right, if we're thinking about and expecting heavier precipitation events, David, I know I mentioned really briefly, I mean, usually your sort of day-to-day focus is a little more around forestry and agriculture in that realm. And I know you didn't really talk a whole lot about that specifically in that economic impact, but I mean, what are these events mean for those industries?
Well, I mean, like Mary said, I think, we're really worried in New England, and the models seem to be coming true sort of sooner than expected. So we're seeing, more rainfall, but also more intense rainfall. So a lot of impacts just on erosion and things like and runoff. So things like culverts sizing, they're washing out because they're designed based on statistics from 20 or 30 years ago. And so I think that's a big thing that I know the Forest Service, for example, is in their lands are certainly considering, future scenarios when they're designing culverts and things like that nowadays, just because, and it seems to be a good thing because it does seem to be ahead of schedule.
Sure. But yeah, plenty of rainfall, and then just the opposite happening even right now in New England is the funny timing, lots of drought as well. We're seeing that, and I guess sort of the opposite issues associated with drought in New England. So with all that said, all right, let's turn it over to the public here, the audience who's joining us tonight. I know we have a lot of good questions coming in. Again, I'll remind you, if you have a question for our speakers, use the Q&A button that's at the bottom of your screen, right in the toolbar for Zoom. We have quite a few that are in here. We'll get things kicking off here. And so this is a more general question from an anonymous attendee here, asking a little bit more about, generally speaking, from a planning perspective, what's the procedure personally for your life and property? How do you plan? What do you do to kind of take care of yourself and your family and your property before an event? I might throw that actually to, I don't know, Ryan, or unless someone else wants to jump in, but Ryan, take a stab at that. I'm sure you know some of the procedures that are often recommended.
Yeah, so if there's potential impact, the first thing you're going to maybe want to do is make sure that the drainage around your house or on your house is clear. So around here, we have a lot of foliage that loses in the fall time. You might not have cleaned that since, the year prior. So you always want to make sure your gutters are clean. Any drainage ditches or waterways around your house are clear and clean. So that way things will just kind of slough off and not potentially dam up and, cause backage issues. In addition to that, if it looks like you're going to be seeing high winds ahead of time, you might want to maybe hire somebody or go out yourself and start clearing some of the loose limbs or tree branches that might be, kind of precariously over your house or have the high potential of possibly falling down. And then if that does occur, at least have a phone number ready and prepared in case you have to call somebody to clear that debris off. And also having a list of supplies and having all those supplies on hand and ready to go. Most New Englanders have that cache kind of ready because not only do we have to worry about these tropical storm type systems, but during the winter time, we see those days on end kind of systems. So luckily, a lot of people will usually have a cache of food and water and batteries and everything else. But if you don't have that, that's when you start, stockpiling ahead of time. And the earlier you do it, the more likely you are to get those supplies because everybody else is going to be panic buying as well. So if you stock up ahead of time before hurricane season even begins, it's one less thing you even have to worry about ahead of time. So those are a few things that you might want to consider if there is a significant storm coming your way.
Yeah, thanks, Ryan. And certainly there are a lot of great federal government resources as well for further information. Certainly NOAA, the National Weather Service, the National Hurricane Center are great places to check out. FEMA ready.gov is a great source to make sure you and your family have a plan for some of these situations that are, we're not too uncommon. We're used to seeing all sorts of weather in New England, but it's always great to have a plan and be prepared. David, I got a technical question for you from Sally. She wants to know, are the costs of the storms equalized for inflation? I wasn't so sure about that myself.
Yeah, those values are all inflation adjusted. NOAA has a great website for, where they list all of the disasters and they updated it with the disasters. You can either get them unadjusted or adjusted, but those were. And kind of interesting, I didn't mention, but Irene was not actually, well, of course, in dollar terms, it was the worst disaster in Vermont, but a lot of folks talk about the flood of 1927 as an even bigger disaster. But it was quite similar in terms of the flooding that occurred, but people were less prepared for it.
Certainly, with a little bit better prediction skills these days, that goes a long way, and certainly the ease with communication digitally. Here's a good question from Deb. I think I might throw this to Mary. Sorry, you probably get the toughest one so far. What recommendations would you make to policymakers to ensure adapting to a shifting climate are in place?
Well, improve infrastructure. And Dave mentioned the culverts. Our stormwater systems are woefully out of date. Most of them were planned based on precipitation estimates that were produced by the National Weather Service back in 1961. So they're woefully inadequate, not even just considering tropical storms, but from our increasing precipitation generally. And what's fortunate about us in New Hampshire is that planning is already happening at the state level. We just did a big report for the Coastal Commission last year that looks at coastal flooding and stormwater systems there, and New Hampshire DES is actively involved in making recommendations to towns and municipalities that are working on improving their stormwater infrastructure.
Yeah, so I'm hearing a little bit of, well, there's stuff certainly happening at all sorts of levels of government, both big and small, but specifically you're talking about the state and maybe even the local and more regional level.
Yeah, because these systems are, they're usually at the town level or in the state level, and it costs money to do this. I mean, in your home, if you have the money, you can do things to help improve, just on your property and with flow and drainage on your own property to protect yourself. But a lot of it does have to happen at some sort of local to state government level.
Great. Okay. And so, all right. Well, thanks, Mary. Appreciate that. Because here's another question. Actually, we're gonna now from climate, let's swap back to weather. And we have a question from Joe. And I know Joe's asking here, Ryan specifically, how do meteorologists predict where a hurricane's path might go? Let's get back to some of it. Sounds like a very basic question, but what are those variables? What are those tools that forecasters are considering? I know you're not a tropical weather specialist, but certainly you know the tools of forecasting. How are we predicting the path of hurricanes?
Yeah, so there are several models that meteorologists typically pull from, and what they normally will do is kind of overlay the tracks of all those various models, and that's where you get the terminology spaghetti plots or spaghetti maps or however you've heard them before. Essentially, it's overlaying all those potential tracks that might be occurring. And what they then do is kind of draw a commonality between all of those various model tracks, and that's how you get that cone of uncertainty. So it's a cone of uncertainty, not the cone of where it is going to go. So the narrower the cone is, the more likely it is going to hit that area, and the wider it is kind of more of the potential where it could go one way or the other. 3 days out, they tend to kind of have a better idea of where things are going to be curving. 5 days out, you kind of take a grain of salt with it and kind of, look at it as, well, maybe that model is an outlier and that's why the cone is so large. And there's a lot of other factors that kind of go into it. They're dropping robber sounds that are or drop of sounds that are going down into the storm to see how strong it actually is, and making sure that the initial data that's going into these models is verifying and not just willy-nilly. So, and as it starts to get closer to land, they can then pull from radar sites as well as observational sites at airports and other locations around the country and around the world, basically, and kind of get an idea and a feel for whether or not it's tracking correctly. And then as the storm approaches a day or two out, they kind of know definitively where it's going to hit. So, the hurricane that is occurring down in the Gulf right now, its track's gone all over the place. But as I was saying, early in the storm, it kind of has an erratic path, but as the storm approaches the coast, it kind of gets more narrowed, and in the 2 to 3 days ahead of time, it's pretty much known where it's going to be hitting. So it's worth preparing for in case you are in that cone of uncertainty, or even a few days ahead of time, but it's as it gets closer that you really have to start paying attention as to where the direct impacts are. But even then, while the center of the storm is going to have the most intense winds and rain, people need to bear in mind with hurricanes, these storms are massive. So it's not just going to be focused on one little area. So, this was affecting most of New England and most of the East Coast as it was moving up. So it's just one of those things where you might not get a direct hit, but it's definitely worth paying attention to because you might get the secondary effects of it.
Yeah. And so, and even, I mean, I guess a simpler, I guess I'm curious. I mean, in terms of steering mechanisms for a hurricane, and I know that sounds probably more complicated than it needs to be. I know we don't have time for a full meteorology lesson here, but what are those features in the atmosphere that actually help determine the path of a hurricane? I've heard things like blocking a high pressure or other things like that. Can you mention a little bit more about that?
Yeah, so it all depends on where things are leading up to where the storm is going to go. So if there are areas of high pressure that are intensifying, that might deflect it, further east or west, depending on where that ridge of high pressure is. So with Irene, there was actually a pretty significant area of high pressure off the coast that was kind of allowing it to skirt and then move up the eastern seaboard. But then inland, there was also another high pressure. So it kind of squeezed between the two. And that's kind of how it shows its course. Now, that isn't always the case. There are other areas of low pressure, frontal systems, the temperature of the waters of the ocean, landfalls, that weakens storms most of the time, winds in the upper atmosphere, various things like that all kind of come into play on where things will track. So there are a lot of variables, and that's why that cone can be so large so far out. And then as things kind of get closer to the event, everything kind of comes into place and puts the pieces in place to know where things are going to be tracking.
Interesting. Okay. Thanks, Ryan. I appreciate that. Let's bring a question back to David. We have a great question from Kenneth, who asked specifically, he's wondering, do streams and rivers recover from heavy flooding events like Irene? And he had some experience from Irene in Vermont. He said he's on the east side of Camel's Hump at Ridley Brook. Basically, it was almost destroyed. The trout fishing hasn't returned. The swimming holes are kind of filled in with all sorts of gravel and boulder. What does it look like for, I guess, the ecological health of some of these systems long term?
Yeah, so sorry to hear that. It can take decades, and some of these big events, they will alter it permanently. It won't go back to what it was, but um, what you probably saw there before Irene, undoubtedly had been flooded probably as badly by that storm of 1927, and probably again by the hurricane of 1938. So you do get recovery, but clearly 9 years doesn't sound like it's enough for this one.
Yeah, just driving through the White Mountains, I can see lots of riverways with that I just know all these boulders. I know they were they were not here prior to this storm, and here's the new pathway that looks to kind of be here to stay for a while to the next one, I guess. Mary, back to you. We got a question from Melissa. She's curious, and I know your work isn't necessarily in modeling at all times, but I'm wondering what you know about how far ahead of global warming models we are. So I know we've been trying to predict the future to the best of our ability, but how well have those performed in comparison, I guess, to hurricanes and maybe some other weather in our area?
Well, for the hurricane projections, they've actually been incredibly accurate when it comes to the increasing in the intensity as well as precipitation estimates. Actually, I think we've seen worse happen faster than the model said. So when it comes to the tracks, so there's a little bit more uncertainty in the model and how many actual storms are going to form. So that's why they don't quite know if there's going to be a change in the number of hurricanes that form. But there is a high degree of certainty that those hurricanes that do will likely be stronger and produce more precipitation.
Thanks. Yeah, I'd certainly, I mean, sort of back to what Ryan was talking about, even for the short-term forecasting, you need to have some good data, reliable data to help you by understanding what's happened in the past that helps us predict the future more or less with the statistics and the math that we have. And the same goes for our climate data as well. And certainly models are our best guess of what we think is going to happen, but sometimes they're not always right. Okay, let's see. What else do we have? We have quite a few questions. Trying to make sure everyone's being heard here. I might hold it back to Ryan because I know we kind of touched on this briefly. I'm sure we have quite a few people joining who are fans of the White Mountains. And Ryan, do you recall, Charles is asking about specifically some damage that you can recall from trails, bridges, roads. I know there's a question even about Dry River Wilderness, that taking such a long time to recover and the trail work done there. What do you recall?
Yeah, from what I recall, the Ellis River definitely got affected, which would be on our east side. The Peabody River flowing up towards the Androscoggin River, both of those kind of saw swelling as well as a lot of erosion. And kind of like you were mentioning, there are places where I see rocks and banks that have been exposed or washed out that I'm like, that was an Irene event. So it did definitely show some erosion and alterations to the riverbanks, even along those. As far as trails around here, I know Tuckerman Ravine Trail saw a lot of downed trees on it that took a while to clear off, as well as the Ammonoosuc Ravine Trail and all the various other trails. The Great Gulf experienced some damage as well because the water washed down there, and then there was also the strong winds that were kind of downsloping into that area as well. So cleanup took a while, but luckily it wasn't anything too significant as far as trailways or whatnot. But I know there were a few roads, especially one of the some of the more unpopular roads that are around the region, took a long while to repair because they weren't critical to the infrastructure. But Route 16 through Pinkham Notch saw some pretty significant erosion and washout of the road on the right there, right-hand shoulder going south towards Conway, and then even the various ravines going more towards our west. Some of those saw some damage to Route 302 and even some, I think, even on Route 3 going through Franconia Notch. So it definitely impacted our region. Not as bad as it impacted Vermont, but we definitely saw some swelling and erosion and trees down here as well.
Yeah, I know the AMC's trail crew, White Mountain National Forest, everyone who volunteers on trails in the White Mountains had their hands full for years. And for anyone big fan of the AMC's White Mountain Guide, for all the trail descriptions throughout the White Mountains after that storm, I think the authors just got tired of saying Hurricane Irene. They just kept referring to damage from the storm after 2011, and I can recall seeing that a lot every time go out to read about a trail. There's usually a mention of the storm, especially if it was near a waterway. All right, so I know we're running a little bit late here. I'll ask just one more question, and this could be a tough one, but a good one, I think, perhaps for David, given what you had spoken about. Keith wants to know, he says hurricane category is not a good predictor of economic environmental damage, and perhaps he has a point based on what you were talking about. What predictable parameters of a storm are better suited for estimating damages? Would the public be better served with doing away with the classical categorization of hurricanes? Well, that's a good one.
Wow, you know, that's kind of beyond my knowledge scope, but I think Mary did touch on it when she talked about the amount of precipitation and, you know, the speed of some of these storms, because you know, Harvey and Florence were really way more damage than you would expect from their categorization, because they were very slow moving and just dumped, you know, huge quantities of moisture. You know, just shooting from the hip, some sort of you know, measure of that might be a better way to you know, start thinking about things.
Yeah, and I know, Ryan, there's some big differences from the Saffir-Simpson scale, so the hurricane category scale, versus the now enhanced Fujita scale for tornadoes. One takes into account damage to human infrastructure, and the hurricanes not necessarily. It's more about the weather, just the general weather variables, right?
Yeah, and actually the hurricane categorization kind of even got stripped of some of its other criteria. It used to factor in things like pressure and other sort of criteria, and that's kind of been stripped to just the winds. But yeah, I think in general, it would be beneficial to, if not, you know, generate an entirely new system, to at least have one running in parallel. Because I think people, you know, with this particular storm where it was downgrading to an extratropical system by the time it hit us, those rains were still something that could be impactful. And I think if there was some sort of coding to at least make people aware that it might not be a Cat 1 hurricane, but it is a, you know, Cat A rain event, that would make people more aware that, okay, it's not so much winds that we have to worry about, it's rain and flooding. So I think the system does need at least modifications, if not an overhaul, to kind of factor in these various parameters that aren't kind of being looked at as closely as they should be.
Yeah, that's a great question, and certainly a tough one, if especially if from a communication standpoint, if you're the federal government and trying to keep the message clear and simple, yet trying to make sure that you're looking at a number of different variables. So thank you, both of you, for the responses there, and thanks to all three of you for joining us tonight. I know we've run a little bit late. I want to make sure I can get to enough questions tonight. But thank you, everyone who joined this evening. Thanks for all your questions. If you enjoyed tonight's free program, please consider becoming a member of Mount Washington Observatory if you aren't one already, and donate to help support the operations here at Mount Washington and to support future educational programs such as these over at mountwashington.org. Also, don't forget, while you're over at the website, you can go to the Science of the Mountains page and check out our upcoming program, which is just a few weeks from now. Tuesday, September 15th, we'll have Dr. Pamela Hunt, who is an avian conservation ecologist from New Hampshire, Audubon. She's going to be talking about bird migration. 'Tis the season in September. So make sure you sign up for that. That's at mountwashington.org, and you can go to /SITM and register there. All right, well, thanks so much, everyone. Thanks again to the panelists for joining, and we'll see you in a few weeks. Have a great night and take care. Bye-bye.
Thanks, Brian.
Thanks, guys. Take care.